in a bid to determine whether distant stars with planets orbiting them can harbor life. The global team of astronomers has discovered a new way to measure the pull of gravity at the surface of distant stars. Knowing the surface gravity of a star is essentially knowing how much you would weigh on that star. If stars had solid surfaces on which you could stand, then your weight would change from star to star. A new method allows scientists to measure surface gravity with an accuracy of about 4%, for stars too distant and too faint to apply current techniques. Since surface gravity depends on the star's mass and radius just as your weight on Earth depends on its mass and radius, this technique will enable astronomers to better gauge the masses and sizes of distant stars. If you don't know the star, you don't know the planet. The size of an exoplanet is measured relative to the size of its parent star, said study co-author and Professor Jamie Matthews from University of British Columbia. If you find a planet around a star that you think is Sun-like but is actually a giant, you may have fooled yourself into thinking you've found a habitable Earth-sized world. Our technique can't tell you how big and bright is the star, and if a planet around it is the right size and temperature to have water, oceans, and maybe life, Matthews added. The new technique, called the autocorrelation function timescale technique or timescale technique for short, uses subtle variations in the brightness of distant stars recorded by satellites like Canada's MOST and NASA's Kepler missions. Future space satellites will hunt for planets in the Goldilocks zones of their stars. Not too hot, not too cold, but just right for liquid water, oceans, and maybe life. Future exoplanet surveys will need the best possible information about the stars they search, if they're to correctly characterize any planets they find. The timescale technique is a simple but powerful tool that can be applied to the data from these searches to help understand the nature of stars like our Sun and to help find other planets like our Earth, explained lead author Thomas Collier from University of Vienna. It will play an exciting role in the study of planets beyond the solar system, many so distant that even the basic properties of the stars they orbit can't be measured accurately. A new method is described in a study published in the journal Science Advances,